All right, so guys, this is number 5 out of 11.3, and it says Alyssa and Gabriel play the following game. Alyssa rolls a die, and if she rolls a 1, 2, or 3, Gabriel gives Alyssa $4. And if Alyssa rolls a 4 or 5, Gabriel gives her $1. However, if Alyssa rolls a 6, she has to give Gabriel $19. So the first part says, let's determine Alyssa's expectation. Okay, so guys, what we're doing here, we're doing the expected value. So let me write that out here for us. Expected value. Okay, so we're going to do this in pieces. The way I'm going to do this part here is, what's the probability that she would roll a 1, 2, or 3? So remember, when we're going to roll a die, we're going to end up with a 1, 2, 3, 4, 5, or 6. So we know that when we're doing the probability, it's going to be out of 6, right? So out of those 6 numbers, how many of them are 1, 2, or 3? 3 of them are, right? So 3 out of 6, and then we're going to put the value. And guys, this here is going to be for Alyssa, okay? So if she rolls a 1, 2, or 3, she's going to get $4. So I'm going to put that amount right here, $4, and I'm going to write it as 4 over 1 because I have fractions, okay? Now let's do the second part. What happens if she rolls a 4 or 5? So again, out of these 6 numbers, how many of them are 4 or 5? Well, 2 of them are, right? 2 out of 6. And if she rolls a 4 or 5, she's going to get $1. So I'm going to put this as $1, again, over 1. And then I'm going to do this one last time. But if she rolls a 6, so again, out of these numbers up here, how many of them are 6? Just one of them. One of those numbers is 6. And she has to give Gabriel $19. So that's going to be a negative, 19. Let me fix that because it looks a little messy. So let's do it like this. Okay, plus 1 over 6. And then a negative, there we go, 19 over 1. Okay, so guys, the one thing I want you to notice about this problem here, look at my denominators. When we multiply straight across, this is still for Alyssa, my denominator is going to be 6, okay? So I'm just going to multiply my numerators. 3 times 4 is 12. 2 times 1 is 2. 1 times negative 19 is a negative 19, okay? All right, so this is going to give me 14 minus 19. That's a negative 5 over 6. And what I'm going to do is I'm going to write that in terms of money, right? Because this is how much money we're going to get. And if you notice right here, it says round to the nearest cent, okay? So let me grab my calculator. I'm going to clear this out. I'm going to say, what's negative 5 divided by 6? Oops, 1 6. Okay, there we go. And it's still not doing it, so we're going to go to math. And we're going to hit the second one so it can convert it to a decimal. And so I'm coming up with a negative 0.83, right? If I go to the nearest penny. Oh, there we go. So negative 0.83. That's going to be Alyssa's expectation. So to show you I'm telling you the truth, let's see, right here, I'm going to enter that in, negative 0.83. Oops, too many 8s. There we go, 83. Excellent. Okay, now what about Gabriel? So remember, Alyssa is going to lose 83 cents on average if she plays this game, like I'm going to make this up, if she plays this game, say 100 times, right? Or she plays this game 20 times. Sometimes she's going to win, sometimes she's going to lose. But if we were to average it out, either those 20 or those 100 times, or even, 50 times, on average, she's going to lose 83 cents. So what's Gabriel going to do? Well, she's losing those 83 cents to Gabriel. So Gabriel's actually going to win the 83 cents, and his is, because he's winning it, it's positive. Okay? And so there we go. All right. So if y'all got any questions, guys, let me know. I'm happy to help.